starts with the discussion. So as the name suggests, the name of the problem is matrix chain multiplication. Now for that you require to have a various operations of matrix, like you should know how to multiply the matrices. The basic condition for multiplying two matrices is the number of column of the first matrices should be equal to the number of rows of the second matrices. So here in this case we are having two matrices, matrix A is there, matrix B is there. The matrix A is having dimension P cross Q, matrix B is having dimension Q cross R, and the resultant matrix will be of P cross R. So here we are not interested in actually finding the multiplication answer, but we are interested in this basic operation, how many these multiplications we require. Means we are interested in finding this number of scalar multiplication, and basically it is going to be equal to P into Q into R, where P cross Q is the dimension of matrix A, Q cross R is the dimension of matrix B. Let us take an example. We are having one matrix having dimension 2 cross 3, and the second matrix is having dimension 3 cross 2, 3 rows and 2 columns. So if we multiply and if you calculate this number of scalar multiplication, they are going to be 2 into 3 into 2. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So total 12 scalar multiplication we require to perform. Now here in this case we are having only two matrices. Now the answer of A multiplication with B or we multiply B with A will not be always true. That is the basic fundamental things, and we all know that. Now to do that particular thing, instead of taking now two matrices A and B, if we are having chain of matrices, say for an example we are having now three matrices A, B and C. So if you have to multiply A, B and C, here you see the name of the matrix chain multiplication problem, the chain word, main important word is chain. So the order should be preserved, right? Say for example, if you are given four matrices like this, A1, A2, A3 and A4. Now there are four matrices. In how many ways we can multiply four matrices? These are the 5 ways. But the most important thing, the order is preserved. Means we can't change the order of A1, A2, A3 and A4. Yes, their multiplication steps we can change. Means first here you see in this is the first possible ways where we multiply A3 with A4 first, then the solution multiply with A2, then solution multiply with A1. So there are total 4 matrices and there are such 5 ways. So the main task that we are going to perform in using matrix and multiplication problem using dynamic programming approach is to find out of these possible path which is the best path, right? So let us briefly understand this problem. So you are given a set of matrices and we have to find out the most efficient way to multiply these matrices together. So the problem is not actually to perform the multiplication, please understand. The problem is not actually to perform the multiplications, but to decide in which order if I will multiply the matrices, then I will be I have to perform minimum number of scalar multiplication. Now I will argue that, so does it really matters the sequence, and will I have the more number of scalar multiplication for some sequences? So to prove that, let us take an example. Say for an example, you are having three matrices. Matrix A is there, matrix B is there, matrix C is there. Matrix A is having dimension 10 cross 100, matrix B is having dimension 100 cross 5, matrix C is having dimension 5 cross 50. So there are if there are three matrices, there are two possible ways in which we can multiply them. Say for example, if can multiply A with B first, then with C, or I can multiply B with C and the result matrix will be multiplied with A. So if I use the first way and if I multiply A with B, so the resultant number of scalar multiplication, if I multiply only A with B, it is going to be equal to 10 into 100 into 5, right? Because it is equal to PQR. So P is the dimension of the first matrix and the Q cross R is the dimension of the second matrix. So here total 5000 scalar multiplication I require. So the resultant matrix D would be of size 10 cross 5. Again I need to multiply it with C. You see, this dimension compatibility has to be there. So the number of column of this D matrix should be equal to the number of rows of the C matrix. Then and only then we can multiply. It is a very basic condition for matrix multiplication. So if I multiply them, again I require to perform 2500 scalar multiplication. So if I add them 5000 plus 2500, so total 7500 scalar multiplication I require to perform if I multiply my matrices in this way. But if I try the another way, so you see how drastically the number of scalar multiplication increases, right? So we have to be careful and we have to choose the best way in which we should multiply our matrices, right? So this is the ultimate goal while you are performing matrix and multiplication using dynamic programming and not the answer of multiplication. Okay. Now before we proceed further, now if we are having three matrices, so there are two possible ways. We have seen in the earlier slides that if there are four matrices, then there are five ways. Now if this kind of general thing asked in the examination, so if two matrices are there, how many ways are there? Only one possible way, because the multiplication of A into B is not equal to always the multiplication B with A. If there are three matrices, two possible ways. There are four matrices, multiplication possible ways are 5. If there are 5 matrices, 14 ways are there. So there is a generalized equation that you require to remember, where you require to find out the Pn value, and it is equal to C of n minus 1. So if there are 4 matrices, we have to put the value of n, it is equal to 4. That will give you C3. And now Cn is defined like this, right? And you have to put these three values in this particular equation. If you put all these values in this particular equation, and you will get the answer 5. So similarly you can get answer 14 as well, you can get 42 as well. So now the basic operation of matrix multiplication. So if we have to multiply A with B, this is a very famous algorithm, and we all know that the time complexity of this algorithm is order of n cube. Here we have considered the dimension of the matrices, that's why it is P cross Q, and the second matrix is having dimension Q cross R. So in general, total number of scalar multiplication requires are P into Q into R. So if we assume these values in general, P is equal to n, Q is also n, and R is also n. So in general, the time complexity is going to be order of n cube. So this particular algorithm everyone knows, right? So we are not going in that much detail, right? Now if you have to perform matrix and multiplication, there are two things you have to find out. The first thing you have to find out, that is a M table. The second thing you have to find out, that is a H table, and you require to remember this equation. This equation will help you to solve matrix and multiplication problem very easily. So the equation is Mij, it is equal to Mik plus Mk plus 1 comma j plus Pi minus 1 into Pk into Pj. Unless and until we go through one example, the equation will not be clear to you people. So you have to just wait till we take one example, and then I will show you how to use that M table and H table. So this is the equation that you require to remember. You have to find out the value of Mij, right? So you have to construct two table. One table is M table. The second table that you have to create is H table. So the value of mij you have to put 0 if I it is equal to j, and if the value of I is less than j, so you have to remember this equation: minimum of I is less than or equal to k less than j. See this condition carefully. Here less than or equal to sign is there, here only less than is there. Mik plus mk plus 1 comma j plus pi minus 1 pk into pj. So basically what we are doing, we are having chain of matrices. So we are multiplying the matrix from I to k, and then we are multiplying matrix from k plus 1 to j, and we are just combining them, right? So using dynamic programming approach, right? So this is also the algorithm for performing matrix chain multiplication. The earlier equation that I shown you, so you have to calculate this equation here, you can use it here, and you have to find out the value, right? So again we are going to revisit this particular algorithm, but before that I would like to give you one example so that you will have better idea, right? So let us consider the case we are having four matrices: a1, a2, a3, a4. A1 is having dimension 2 cross 3, a2 is having dimension 3 cross 4, a3 is having dimension 4 cross 2, and a4 is having dimension 2 cross 1. The same thing can be given you in the examination in the form of P0, P1, P2, P3 and P4 form. Say for example, the first matrix is having dimension 2 cross 3, that's why the first dimension value will be P0. So here in this case the value of P0 it is going to be equal to 2. P1 will be 3. Now you see the second matrix should be compatible with the first matrix. So here 3 is there, so here also 3 is there. That's why, so this 3 and 3 is repeating. So this value we don't have to consider for P2, but the next dimension we have to consider for P2. Same way you can find out value of P3 and P4 as well. So once you do that, you have to create two tables. Now as there are four matrices, so we have to create two tables. First table is your M table, second table is S table. S table will actually store the value of K, right? And we'll see how to calculate these values, right? So there are four matrices, so you have to write down like this: 1 2 3 and 4, 1 2 3 and 4. So 4 cross 4 matrix you have to generate, okay? And again these cell values we have to find out. So this is the directly answer I am right now showing you, but we are going to see in detail how these values are calculated. But if you remember this particular equation, right? So whenever the I is equal to j, we have to put the value 0. Means let us say if this is my M table, so M11 value will be 0, M22 value will be 0, M33 value will be 0, because I it is equal to j. You can assume here it is your I and here it is your j, right? M44 it is going to be equal to 0, and at that point of time whatever the value of k you have considered, you have to put here. Right now don't get confused, right? We will see one by one how these values are calculated. So the first thing should be clear in your mind. First, this diagonal always will be 0 whenever you go for any matrix multiplication problem. Here we are having 4 matrices, but in the examination you may be given 6 matrices, 5 matrices, 3 matrices, any number of matrices, right? But this diagonal always going to be 0, because always I it is going to be equal to j. That's why M110, 220, 330, 440. Same way you can have 550, 660. But here we are having only 4 matrices, so only the matrix we have to create of 4 cross 4. Now the next value what you have to find out. Let us say if you are having 0 here, the next value that you can find out, you have to see the difference between I and j. If the difference here I equal to j, means there was no difference. Now you have to go for one difference, means what value you can find out. Let us say 1 is here, 2 is here, so I equal to 1, j it is equal to 2. That's why the difference between them is 1. So you can calculate the value for M12, M23 and M34. So subsequently at the end we are going to get the value of M14. This will give you the minimum number of scalar multiplication you require to perform. And after that, one algorithm POP, that is called print optimal parenthesis, that you have to apply to find out the optimal way in which we should multiply our matrices to get the optimum number of scalar multiplication. So let us calculate these values. So as we have already seen, M11 equal to M22 equal to M33, M equal to M44, always it is going to be equal to 0. The next value that we have to find out is M12. Now we know this particular equation, right? Here the difference between I and j value is only 1. So you will be having only one equation. When you will find M13, so the difference between 1 and 3 is 2. In that case, you will be having two equations, right? So in the first equation, you have to take the value of k, it is equal to I, and in the next equation, you have to increment the value of k by 1, means k it is equal to I plus 1. So in that case, you will be having two equations. So see this equation carefully. So in that case, you have to consider the minimum value. So if you are having two equation value, so the minimum value you have to consider, and at that point of time, whatever the value of k is there, that you have to put in this S table, right? So let us first understand how this M12 is calculated. So we have just put this equation mik plus mk plus 1 comma j plus pi minus 1 into pk into pj. The value of I, here you see I it is equal to 1 and j it is equal to 2. We are actually finding the value of mij. So it is equal to m, I is 1. Now initially k it is equal to I, and as the difference between 1 and 2 is only 1, so k will always be equal to I only. That's why 1 plus k plus 1, right? So here there is a bit mistake, so that you can correct. So here you have to write down 2 2 m22 plus p0 into p1 into p2. How? So I equal to 1 if I put p0 into pk. So the value of pk is P1 into P2. So you will get the value 24. So M12 value will get 24. So we have to put this value here. And at that point of time, what was the value of K? The value of K we consider equal to 1. That's why in S table M12 we have to put this value, that is 1. Right? Now let us calculate the next value, that is M23. Again the difference between 2 and 3 is 1. So I have written the equation and I am now putting the value of I and k. I equal to again 2, k it is equal to I, that's why 2 plus k plus 1. So 2 plus 1 is 3 comma 3 plus pi minus 1. So the value of I was 2, that's why p1 into pk. Pk is 2, that's why p2 into p3. Now this p1, p2, p3 value, from where we have to see, here we have already considered the value of p0, p1, p2, p3 and p4. So sometimes in the examination, instead of giving this dimension, direct value of p0, p1, p2, p3 and p4. So if the values are given like this, 2, 3, 4, 2, 1. So you have to understand the dimension of the first matrix is 2 cross 3, the dimension of the second matrix is 3 cross 4, the dimension of the third matrix is 4 cross 2, and the dimension of the fourth matrix is 2 cross 1. Right? So same way, if you put all these values here, you will get the value of M23 is equal to 24, and you have to put this value M23 it is equal to 24, and at that point of time the value of k was 2, that's why I have written 2 here. No. Right? So M34 it is equal to mik plus mk plus 1 comma j plus pi minus 1 into pk into pj. So if I put the value of I and k same way as we did in the earlier slide, right? So M33 plus M44 plus, if I put the value of I and j and k, p2 into p3 into p4, right? And if I calculate the value of M34, I will get it is equal to 8, right? Now the most important thing, this was very easy when the difference for I and j was only 1. But sometimes the difference between I and j can be more than 1. So here in this case it is 2. So you will be having two different equations. In the first equation you have to take the value of k it is equal to I, and the second equation you have to take the value of k it is equal to I plus 1. If you are having three difference, then again you can go for k it is equal to I plus 2, like that. So here why we are doing this, because due to this condition, because we have to consider the value of k till it is equal to I. So I is less than or equal to k, less than j. So if difference is 2, you will be having this kind of two different equations. So if you have to calculate m1 comma 3, so we the difference between them is 2. That's why one time you have to take k equal to I, and in the second equation you have to take k equal to I plus 1. So here I have taken k it is equal to I. So mik plus mk plus 1 comma j plus pi minus 1 into pk into pj. So if I put value of I equal to 1, right? So here this is your I, this is your j is 3, I is 1 here in this case, and k it is equal to, initially what you have to take, it is equal to I, so m11 plus m23 plus p0 into p1 into p3. So if I put again, so m11, you see, the main advantage of dynamic programming is it is not allowing you to calculate the same stuff twice, means it is actually reducing your calculation, because here you see m11 calculation is required, but that we have already calculated here. So m11 equal to m22 equal to the value we have calculated is equal to 0, so that value is being stored in the table, so that's why we can use that particular value here. So m11 it is going to be equal to 0. m23, this value we have already calculated, so we don't have to calculate the same stuff twice, right? And we can utilize the value stored in the table, so directly that value is being calculated, so you have to utilize that, plus p0 that we know p1 is 3 and the value of p3 is 2, so we are going to get the value 36. Same way, if I will take k it is equal to I plus 1, so instead of here we take k it is equal to I, so 1, but here we have to take 2, so same way here it will become 3 3 plus p0 into p2 into p3. So if I put all these value, m12 we have already calculated, the value is 24, plus m33 is 0 because I equal to j, plus p0 value is 2, p2 value is 4, p3 value is 2. So if I calculate this particular equation, I will get value 40. So now you see I am having two different values. One value that I am getting is 36. The second value I am getting is 40. Which value is minimum? 36 value is minimum. So that value M13 value it is equal to 36 you have to consider. So M13 it is equal to 36. And why we have written 1 here? So here 36 value when we considered at that point of time, what was the value of k? It was 1. So it is k it is equal to I. So the value of k was 1. That's why S13 I have to write down it is equal to 1. I hope that's clear. Let us calculate one more stuff. M24 value. So M24 it is equal to, again you see the difference between 2 and 4 is 2, right? So in one equation you have to take k it is equal to I, in the next equation you have to take k it is equal to I plus 1, and if you put all these values you will get the value 20 in the first equation, the value 30 for the second equation. The equation 1 is having the lesser value because 20 is less than 30, so we have to consider this particular value. So M24 value we have to consider, I have made a mistake here, so you have to consider 20 here and not 30. M24 value you have to consider it is equal to 20, right? And at that point of time, whatever the value of k, right? So here in this case 24, right? So 20 value you have to consider, and at that point of time the value of k it is equal to 2, so that all I have to consider. Now only the last value is remaining to be calculated. So M14, now the difference between 1 and 4 is 3. So instead of now having two equation, now you will be having three equation, because 4 minus 1 is 3. So k it is equal to I, k it is equal to I plus 1, and k equal to I plus 2, and you have to redesign these three equations, right? And you have to calculate the value for each equation. And now you see this is my equation number 1, this is my equation number 2, this is my equation number 3. So but equation 1 is having value minimum, that is 26, and at that point of time the value of k was 1, right? So I have to consider the value of M14 it is equal to 26, and the value of k in the S table it is equal to 1, that I have to consider. So once your M table and S table is ready, right? This is your M table, this is your S table. Once these table are ready, right? So there is an algorithm to calculate this M table and S table. So let us just quickly go through that particular algorithm first, okay? And then we'll come back here, right? So this is what we have done. Mij it is equal to 0. So here the loop is for I equal to 1 to n. So n is what? The number of matrices. So M11, 220, 330, 440, and so on. And for all these looping concepts, right? All these loops, how, for what purpose they have used? they are used for all the remaining cell values, and initially those cell values we are considering infinity, right? And for those remaining cell values, what now we are doing, we are calculating these values, right? So the equation is very well known to us, right? So that too much calculation we have done already. Mik plus mk plus 1 comma j plus pi minus 1 into pk into pj, right? So earlier the value we considered was infinity, so whenever you are having lesser value, that lesser minimum value we have to consider. That's why the value of mij, it is going to be equal to q, and the value of sij, it is going to be the value k. So and we are returning the m table and s table. So this is how we are now going to use this m table and s table. So once you calculate this m table and s table, that particular algorithm is known as matrix chain order, right? Where we are actually calculating the matrix chain m table and s table, right? And those tables we are going to use for print optimal parenthesization, right? So once m table is known, s table is known, but actually what will be the sequence? So this is an algorithm that you are going to follow. If the value of I is equal to j, then you have to print ai, else you have to print opening bracket. Again you see the same function is called recursively, so it's a recursive call. So print optimal parenthesis, again s comma I comma sij value you have to get here, right? So this is also sij value, this is sij value, this is sij value, right? Again the same algorithm function is called s comma here up to sij. Now here you have to write down sij plus 1 comma j. So ultimately our goal is to multiply from I to j. So let us take trace our example that we took, right? So if pop it is equal to s comma 1 comma 4, here you see the argument that we are passing are s comma I comma j. So here in this case s is going to remain same as it is for s table. I is 1 because we have to start with 1, and j value is total how many matrices are there? So total 4 matrices are there, right? So we have to write down s comma 1 comma 4. So this pop is a short form for this function name print optimal parenthesis, right? So pop s comma 1 comma 4. Now when I pass this particular thing as an argument here, so s comma 1 comma s14. Now s14 value, here you see, you have to see now in the s table, right? Here you see m table usage is only to find out the minimum number of scalar multiplication you require. So m14 value we calculated, so this 26 is the answer, that these many number of scalar multiplication you require to perform when you will multiply these 4 matrices. Now to find out this optimal way, this s table is very important. So here s1 comma 4. So s14 value is 1, right? So that's why you have to write down here s1 comma 1, and pop, again this second pop is also called as sij plus 1. So sij value was 1, so here you have to write down 2 comma j value was 4. Here you see the same value is being given here. Now as we know, now you see the condition in the pop algorithm, I equal to j, then what you have to do, you have to just print ai. So opening bracket pop s comma 1 comma 1. Now here you see I it is equal to j, so what you have to do, this opening bracket as it is, and we have to print ai, and the value of I it is equal to 1, that's why we are printing a1. Same way when you call s2 comma 4, so again s24 value you have to see. So here s24, that value is 2, that's why pop s comma 2 comma 2, and here sij plus 1. So यहाँ पे 2 है, तो यहाँ पे क्या हो जाएगा 3. So s comma 3 comma 4. Again here you see 2 and 2 means I it is equal to j. So again opening bracket and you have to print a2. So this opening bracket we are writing as it is, right? So if you just write down this sequence as it is, this will be the solution. So this is the sequence in which we should multiply our matrices, so that we'll be having minimum number of scalar multiplication, and here in this particular example there are 26 scalar multiplication you require to perform, and this is our final answer in this order. If we will multiply, because we know for 4 matrices there are 5 possible ways, but this is one of the best way where you require to have minimum number of scalar multiplication to perform, right? So this was the Now let us we have seen already the example. Now we are going to go through some theoretical stuff, right? So there are n matrices, right? So and we would like to multiply these matrices, right? So for that, what you have to do, we have to subdivide the problems into sub problems, right? But here the main advantage compared to this greedy approach is it is guaranteed that you will have an optimal solution, right? And the second advantage compared to this divide and conquer strategy is that you don't require to calculate the same stuff twice. Once you have calculated M12 value, you can utilize whenever it is required, because we are going to store those value in the table. So if you are having matrices from AI to AJ, so first what you have to do, you have to first compute the matrices 1 to K, then K plus 1 to N, right? And there are several yes, all these recursive calls we know how to calculate, right? So all these things we have already seen, right? So this pi minus 1 into pk into pj, it is a cost of multiplying, it is a cost of multiplying. So this, let us try to understand this aij means what we are doing, we are multiplying the matrices from I to k, then k plus 1 to j. So aij is the cost of computing aik plus cost of computing a k plus 1 comma j plus cost of multiplying aik and a k plus 1 to j, right? So again the same equation, right? So we have done so many calculations, so we are not going to, so this is a very important equation if you have to perform the matrix chain multiplication. So this equation m table and the value of k will form the s table for you people, right? So it's very important equation. So if you remember this particular equation, then you will be able to solve dynamic programming problem for matrix chain multiplication very easily. You also have to implement this particular problem practically, right? So that guidelines I have already posted on the Google Classroom, so that you can refer, right? And this recursive equation, right, recurrence equation for this matrix chain problem, t of n, it is going to be equal to 1 if only one matrix is there, so it is always going to be 1. Otherwise, if for any other case, sigma k equal to 1 to n tk into t of n minus k for n equal to 2 or some higher value, right? So this is the algorithm for finding the m table and s table that we have already seen, right? Okay, let us talk about regarding the time complexity and space complexity. As all the operations are performed on a matrices, so the space complexity is going to be order of n square, because we know for matrices it is a 2 dimension, that's why order of n square. And the time complexity is going to be order of n cube, because you see these are the 3 for loops, right? So this is the inner for loops, right, where we are calculating the value of m table, right? And that's why n into n into n, so it is going to be order of n cube, right? To refer the reference material, I advise you to refer this particular book, Thomas Corman, right? Introduction to Algorithms by Thomas Corman, right? So this dynamic programming approach is very well explained over there, right? And there are several examples that you can solve there, right? So if you are having any query question, you can write down in the comment section. Thank you, students.